Okay, thank you for the invitation, and it's nice to see so many people. So I would like to present the following theorem. So the theorem says, suppose V satisfies ADR plus axiom C1, then if you force with Pmax followed by adding a Cohen subset to omega 3, then for any kappa that belongs to the set of omega 1, omega 2, omega 3, the omega club filter restricted to HUD is an ultrafilter in HUD. It's an ultrafilter in HUD. So some history. This is related to Wooden's HUD conjecture. So let me review. So suppose delta is extendable. Then exactly one of the following holds. Okay, so one, lambda is a singular cardinal. Rather than delta, then HUD computes its successor correctly, then lambda plus of HUD is equal to lambda plus. And 2, for every lambda is a regular cardinal greater than delta, then lambda is a measurable cardinal in HUD. Then lambda is a and Wooden was asking if we drop delta being extendable, can one force possibility 2, which is the less desired possibility? We would like to prove that possibility 1 doesn't happen. Possibility 2 doesn't happen, so that we have covering, i.e. that HUD is close to V. So 2 is the not desired property. And so Wooden was asking, if you drop the extendable, can we get 3 regular cardinals in a row that are measurable in HUD? And recently, Omer and Yair proved the following theorem. It is consistent relative to a strong cardinal that successors of every regular cardinal of every regular cardinal is measurable in HUD. And in their model, what they do is they get that the omega club filter restricted to some stationary set is ultrafilter in HUD. Then they asked the question whether the omega club filter itself can be ultrafilter in HUD. I mean, of course, you want to do this with extendable, right? But at any rate, it wasn't known how to get even 3. What they do is, in their model, they get that the omega club filter restricted to some stationary set is an ultrafilter. So they ask if you could do it for just the club filter itself, right? So the theorem answers their question. The question was, can you in fact get
if you start from extendable, you lose it after doing their argument, or?
Oh yeah. No, it kills the extendable. Kills super.
But they start from an arbitrary model of DFT, or they have to start from
No. They start with the small.
with an inner model?
Yeah, that is some small.
And then do class force?
But I'm not sure if they need it. I mean, the forcing would definitely kill. They in the paper, the way it's written, they do start with some minimal model. But Omer was telling me it's just for simplification of arguments. So I don't 100% know
But
if.
the class force.
Oh yeah. But it will kill the extendable. Can you get that the omega club filter? Restricted to. I mean, this is specifically asked there, why exactly omega 3? Well, because that was the first case we don't know. Omega club filter restricted to HUD. The omega club filter on omega 3 restricted to HUD is an ultrafilter in HUD. Why specifically omega 3? Because omega 1, omega 2 is known. You just force it by Pmax over L of R. Right? And you get that.
What's the connection between that question and that theorem?
Well, here they get the weaker version where it's omega club filter restricted to some stationary set. Yeah? I mean, there's more to what I'm saying. The Kopf omega points are important here. So there's something called omega strongly measurable, and they actually do that version. So they prove a stronger theorem, but anyway. Okay, so they ask for omega 3 because, so why omega 3? Because in this model you get for omega 1 and omega 2. Because, why do you have this? Well, and that's the same idea in the other proof. Because omega 1 and omega 2 in the AD world already have that property. They are the omega club filter restricted to HUD of L of R is an ultrafilter. So all you do, you force choice, but the forcing is homogeneous, you don't change HUD, and then you get it, basically. Okay, so omega 3 was an issue. Why was it, is it hard?
Sorry, what you just said, that would mean that if you change Pmax into kind of like all omega 1 R.
Oh, but that's the thing. Then you have, I mean, Pmax keeps omega 2, yeah? The other one would make omega theta, omega 2, then you need some theory about theta. If you do that version, if you do this version, and do the forcing you mentioned, there you have omega 1, omega 2, but you want omega 3, not omega. Okay. All right, so let me also tell you why I like this problem.
You said what is the CI?
I will say in the C1 actually. It's,
So you make a 3 going from D to your generic function?
I'm sorry, can you say it again?
Yeah, it's
So you start with B, some B, which
Yeah.
is ADR plus some.
Right.
So cardinals omega 1, omega 2, omega 3 are the same as in B?
No, now omega 3 is theta.
Okay.
Yeah, I will say it in a moment. Here, the omega 1, omega 2 are the old ones, and you have what you want. There, omega 3 is theta. Now we don't really, if you just force over the known models of determinacy, you'll never have this. So you'll have, I will talk about that in a moment. Why do I like this? Because, why is the title forcing over models of determinacy rather than the theorem? Okay, so some. Well, traditionally, we do forcing over large cardinals, right? And the two theorems that I like, and I'm sure other people like other theorems, here is one. So you do from huge. from huge. Okay, so you start with something extremely big, and you do that. And the other, of course, Forman. Right, so this is the classic theorems. Here you start with the huge, you force CH plus omega 1 tensor delta omega 1. In the other case, you force a non-CH theory. Here you have a nice CH theory, right? This, I mean, math has higher versions of this with nice applications in infinity combinatorics. So this is a CH theory, and you also force non-CH theory from Rash-Carnot. But you can get that from determinacy. So you can do so forcing over models of AD. Okay, so here is a strong theory. So this theta is regular basically. So this is going to say that ZF is true plus ADR. So this is the same axiom. Plus theta is regular. Theta is the least ordinal which reals cannot be surjected, right? It's the successor of the continuum. So think of the least ordinal such that there's no surjection from reals onto it. Okay, so that's theta. All right, so here's for the first one. It's again wooden. Suppose V is equal to L of power set of reals plus this, and V models theta reg, right? So it's a model of this theory. Then, okay, so you want to enumerate reals of in order type omega 1. So you collapse the reals. I should say that DC holds. So if you're wondering why this doesn't do too much damage, from this theory you can get DC. And so that's accountable forcing doesn't net reals. Accountably closed forcing doesn't net reals. And then you add a Cohen subset to omega 3. Why omega 3? Omega 2. Why omega 2? Because theta becomes omega 2. And then if you want to get choice, you have power set of reals, you have to enumerate well-ordered power set of reals. That's why omega 2. Okay, so what do you get here? You get exactly 1. CH plus omega 1 dense ideal on omega 1. Right, so this is the CH theory, and you can do the Pmax version, which will give you the second one, but not full version. Oh yeah. When I start talking about CH, I mean.
But it's the same if you put omega 2 or power set of R, because it's not transparent that if you add the subset of omega 2, you are well ordering the power set of R.
Yeah, I mean, if you want me, I can, yes, you could do it that way. Yes, it's not transparent, but there is, let me not do that, yeah, because that, but it's not that difficult to see because you have reals are well ordered and theta is omega 2, and you have under AD, you have a surjection from, yeah, so this. And the other one is again, it's wooden. And same theory, same hypo. The forcing is different than, okay, so you change now you have to do omega 3. Why omega 3? Because theta becomes omega 3. Okay, so this is going to have mm. C is the continuum, so you just get minus maximum for posets of size, the continuum. I think you don't want to put omega 2 here because I'm not sure if that implies 2 to the omega is omega 2. This implies 2 to the omega is omega 2. Huh? So if I put omega 2, I'll already have. This forces that, implies that 2 to the omega. Okay. And then plus, you can get also omega 2 pre-saturated ideal, but I don't. You can get more. You can get omega 2 pre-saturated ideal, omega 3 pre-saturated ideal on omega 2. Okay, so it's like the same. So the question is, can we get, so this is the CH version, but it's about what? It's about omega 1 and omega 2. This is the non-CH version, but it's about omega 1 and omega 2. The question is, can you have, at least the question I'm interested in, if you can basically have CH version for bigger cardinals and non-CH version for bigger cardinals. So basically the question is, can you force mm and if you do, your model cannot look like that. Because, so here is a remark. Okay, so remark is over let's see. Emacs and then something else, whatever you want to put here. Simply because Pmax is going to make that of size omega 2, omega 3, size omega 3. And this is going to imply that every subset of omega 3 has a sharp. So you'll have PR sharp in the generic set. It can't happen. All right, so what you need to do if you take this project seriously, you need to start developing higher type of determinacy theories that talk about power set of reals. All right, so need to answer the question, we need for example, that talks about basically power set of reals. Sort of a canonical theory, of this is what you need. Okay, and that's the theorem I stated at the beginning. That's just one type of thing that works, the ground model. So for me, the interest is in the ground model, so not so much in what you get after forcing. It's a curiosity, but it's a test question, right? So you develop a theory of higher type models and you ask, what can you force? What sort of applications can there be? Okay. Let me see if I missed anything. Oh, yeah, let me tell you two like why did we even think that this would be ever possible? This. That was because sometime it was one of these square meetings, and we forced forced mm not which, okay, so we forced that, but we didn't quite force it by developing higher models. So this theory does not yet tell you that you need to go beyond L of P of R. Maybe a little bit, but not too much. Because you just, remember, this is something about omega 3, it's not about omega 2, right? So this doesn't say that you need drastically different structure on the top of power set of reals. But it's a step forward, because that constant can force over model of terms.
Because there is some model, there is no
Some model. I mean, it's hard to say what the models are, because I will tell you at the end with some inner model theory. But these models were still of that form, more or less, right? Okay, so then the question was, the important thing is that the sub omega 2 is not a consequence of mm plus plus c. You need mm plus plus c plus for that. Okay, so this is a consequence of c plus, not the c. And then more recently, forced mm well, of course you get actually this one, and you get that one. Okay, so this has to go already significantly beyond power set of reals, because now your theta is omega 3. They together will tell you every subset of omega 3 has a sharp, so that means you have a lot of stuff on the top of power set of reals. You can't get something like that over models of that form. You need to have significantly strong structure. And over the one curiosity is that the hypothesis was weaker than Limit of Woodens. So this theory is weaker than Limit of Woodens, right? So the corollary was the hypo of this theorem, right? Is weaker in this consistency strength sense than the consistency of ZFC plus there is a Wooden limit of Woodens. And then there was another corollary of this fact via a theorem of Jensen, Schindler, Schimmerling, and Steele, that the KC constructions don't converge. So ZFC does not prove that the KC construction that Michelin, Ruff had, this is the Mitchell-Schindler KC construction, ZFC does not prove that this converges. So that was one of the ways of proving that PFA gives you an inner model with the super strong. You would prove that ZFC gives you this KC construction converges, and then you'll use, and then they proved that if you have failures of squared, this model will have super strong, right? So that was the program. So okay, it cannot work for this particular KC, But then the question is if you can do one level higher. Okay, so there are a few reasons you would like to think about this type of problems. One, which is my true interest, is what sort of determinacy theories you could put on the top of the power set of reals. And then there are these applications which to me are surprising because you wouldn't relate determinacy to things like, okay, this kind of seems like magic, right? But then you start getting more and more, you start thinking that maybe there's a deep connection. So in fact, I would say maybe a bold conjecture, I don't know, is mm plus plus implies L of O is contained in the class forcing extension of some definable model of AD. So you can, I would even conjecture that it should be Pmax followed by something, and it should be homogeneous and countably closed. To me, this would be, okay, I don't really understand Matteo's theorem that mm plus, that mm, so he proved that mm plus plus with another plus implies that you cannot change this theory by semi-proper forcings. So, yeah? So I don't really understand the theorem unless it goes through something like this. Okay. Yes. It's obviously right, it's generalization of star. What does star say? Star says the same for omega 2, omega 1, essentially, right? Axiom star. Okay. So let me do the thing. Yeah. No, this is not a model of choice. Yeah. I mean, we know that mm plus plus implies, right? Okay, I'm not writing it, but I don't know, but if you have class of measurables, this is not a model of choice. So I don't know if mm plus plus actually implies this. This I don't know. But if you have class of measurables, so if you had mm plus 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 class of measurables, that would be true. But probably I'm just mm plus plus. Okay, so graduate students, that's it, right? Justin's question is.
The theorem I have is with that cardinal, so in that context, choice will take it.
Right.
Because the theorem is not just mn plus plus.
All right, so here's.
Mn plus 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 plus.
Does this imply L? Not this. Should be true, yeah? If you assumed mm plus 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 class of measurables, so it's just tiny bit more, then you have it. And it's true for, if you put omega 1 here, then it's just axiom star. Yeah, omega 1 to the omega 1. That's just axiom star, right?
Okay, so that's a star.
Yeah. So this is a generalization.
Some kind of global version of star.
Right. Yes, exactly. And then what does Matteo's theorem say just for omega 1? It would say that generic extensions with semi-proper forcings, you cannot change the theory of L omega 1 to the omega 1. But that's because we cannot change the theory of L of R, not because of some. And so here you would have why can't we change the theory of this? Because we can change the theory of the determinacy model. No, that would be an explanation. Okay. So let me tell you what the model is. How much time do I have, by the way? Until 12? Until 15 minutes. So. Okay, so I'm going to talk about hot mice without telling you what they are. So I want to state the sort of the background theorem that gives you the model over which you force the first theorem I stated about omega club filters, right? So assume V is a hot mouse. Okay, you don't really need to know what hot mouse means. It just means V knows how to iterate itself. V has an iteration strategy for itself. Okay, maybe I can even say what I suspect could be this model. Maybe it would be better to say that than some technical stuff. So this is not the complex numbers. CBL so let me put gamma infinity because I got used to putting gamma infinity. Is the set of UV sets. Set of universally Bayer sets. Mu alpha is the club filter on the omega 1 of alpha. Right? So the question is, can we use C for the modelable for that purpose? Okay, so it looks too small, but LOR is also too small. If somebody told you that, power state of omega 1 on the MM is just Pmax extension of LOR. LOR is too small, yeah? But this C is also too small, but maybe it could work. At least I don't know why it wouldn't work, right? So, yeah.
So yours, conjecture is that DC is the model over which you force, this satisfies AD?
Yeah, so I don't know any of that. I know that this model can satisfy AD in hot mouse situations. So if you compute this model in generic extension of hot mouse, that will happen. So there are instances of this when you think V is an ultimate L, V satisfies ultimate L, then if you collapse the supercompact, you'll have this, right? So seems natural to think maybe you already have it. So I don't know if this satisfies AD. There's another question. Even if it satisfies AD, does it mean these guys are actually okay, there will be measures. If they're really internally the club filters, there's some questions like that.
Is it a good candidate for PI?
Yeah, so I would try to investigate the Pmax extensions of this model. The thing is, the only cases where I know where this model had applications is when you force over hot mouse. So if you collapse something in a hot mouse, you look at this model, and then forcing extensions of that model satisfy nice things.
So
but
you say just
in V, I don't know.
Pmax, we would get class force.
Class force.
But any guess what the club forcing would be?
Uh,
I mean, if we
well, I would suspect it's just adding coin subsets to everything. That's what works in the other contexts.
I mean, so Pmax followed by a main coin.
Yeah. At least I don't know why that doesn't work. So prove me wrong, I'll be super happy. All right, so let me go back to this. So here, what we do is we build a version of that model, and then it has applications. And delta so eta is a inaccessible delta less than eta is a wooden, and kappa less than delta is the least. Less than delta strong. So also assume kappa is a limit of woodens. Okay. All right, so it's some kind of large cardinal configuration. And okay, so what we do, we look at the derived model. So let G be generic, and then B be the derived model of B at eta as computed by G, compute by G. Right, so you look at all these sort of universally bare sets in V of G, and then you look at L of that model, right? So let H be hot up to theta as computed in D. And then you need to look at the iteration embedding from V into hot. So in this context, V actually iterates into hot. So let J from V into hot be the iteration embedding, which this is the key fact which we don't have in V. You don't have the V embeds into the hot of the derived model. Ultimate L implies that. This is something that ultimate L implies. We don't have this kind of thing just in V. With the iteration embedding. And okay, so now you want to look at where kappa plus goes. So let lambda be kappa plus of V, and X be sort of J restricted to V, J restricted to H lambda. Okay, so there's a lot of notation.
So X is the max or the
X.
point where it is
It doesn't quite matter because you would compute one from the other, so you can think of both. Okay, and so then, so now we look at, okay, so let delta be in the derived model, right? Delta is the set of reals whose weight rank is below the image of kappa. For people who know inner model theory, this should make sense, right? So image of kappa is a member of the Solvay sequence. Okay, and okay, so now let W be L of sort of hard, so H. I'm putting the entire H up to JF lambda countable sequences. In fact, you can prove this is equivalent to just putting that X in there. So why don't I just put X? I really want all countable sequences, but by putting X in there, I can compute all the other ones. So let me put X, right? Delta, and that's it. Then, so this is a type of chunk model. Is this type of model? Just adding this X adds all the countable sequences from, as I was mentioning, from JF lambda, right? Well, I mean, you have to prove it. It's not obvious, but that's what happens. And delta itself, there's a theorem of ADR that every set of reals is ordinal definable from a countable sequence of ordinals. So here I could just put, instead of delta, I could just put j kappa to the omega. That would be equivalent to putting delta. Okay? All right, so this is that type of model, and then you force, so then if you do Pmax now, and the Cohen subset to omega 3, this will have the theorem that I stated for every kappa in the on Crop filter restricted to hard. Is an ultra filter. And the proof is kind of the same for omega 1 and omega 2. What we do is, by some determinacy stuff, we already know that this j kappa, by the way, j kappa itself is now theta of W. We know already that that's measurable in H, and so what we do is we prove that basically the W is ordinal definable here. The model can recover W, and then you have to argue a little bit that that measure is actually the omega club filter base. And so there's some work to do, but that's how you do it. All right.
Question?
So, and this model would look like an initial segment of T, up to which height?
J kappa. We have
which is
well, I don't know
compared to theta, where is the?
I mean, this is really bold stuff. Yeah, I don't know if I don't understand this model under MM at all. Mm-hmm. But in this model, in this universe, if you cut C at j kappa, which is some member of the Solvay sequence, I don't know what, then that's what it is.
But for example, would this, compared to that one, in this model, the countable sequence you're putting in are above theta or are?
Oh yeah, that's the whole point. This X, j kappa is theta of this model, and you added countable sequences from the successor of theta, right? So you have. So what you have done is in this model, you took H up to theta plus and all the countable sequences. And if you don't do this, theta plus becomes a cardinal of. So if you forget X, this theta plus of what? Right, so theta plus of H. So if you just do L of H delta without X, this is the successor of theta. So you killed the successor of theta by adding this countable sequence, right?
So I'm not sure if this is is it reasonable to ask if MM++ holds, does the omega 1 Chang model satisfy MM++? even though it's not I mean, it's not a choice model apparently, but it's still presumably choice. I mean, has enough choice in it that that's maybe a reasonable.
Yeah. So yeah.
And if the answer is yes, is it reasonable then to try to force to recover choice while preserving MM++?
Yeah, but I don't somehow I don't believe that this model will satisfy MM++. I don't.
Okay.
But yeah, I mean I don't know anything about.
Does it change things if you instead of the omega-1 Chang model, you kind of enrich it in the way that you enrich the omega Chang model, right?
The omega-1 Chang put the club filters. And
you
things.
throw in the
Yeah.
universally bare sets. You throw in the club
Right.
filters.
Yes. Yeah. I think that's still possible. Yeah.
Okay.
It's just.
And it's so just to ask a concrete question, it's not known if there's a super compact cardinal, then this boldface C satisfies AD.
No.
It's not. I mean, it's an
not
open
even
question, or it is known in the answer.
No. It's an open question. It's not even known if you do the more reasonable thing, which is collapsing super compact to be omega-1. I think that would be probably more reasonable to expect that it would be. Or maybe first force sealing and then do something.
Okay.
Yeah, nothing is known. It's not even known if a more reasonable model is to look at, you collapse the supercompact to be omega-1, then look at did you say AD? Okay, AD is a little bit, if you do the symmetric extension, if you collapse kappa to be omega-1, then that cannot satisfy, I think, AD, because the theta of gamma UB has size, in that model has size omega-1. And then you'll be just adding an enumeration of theta. Yeah, so that's probably not going to happen. But the question still would make sense. Yeah.
Okay, so we don't have much time. So let's thank Grigor again.